Okay, let us discuss this problem. This is something related to writing mechanism. So let us copy the problem and then you have to write down the mechanism. So benzene reacting with some kind of ether. So this is a ether. O oxygen that is attached to two-side alkyl group. So this is a ether. So ether you have, and here you have a benzene. So benzene is reacting with ether. So you have to give me the product in this case. Product is given to you, you have to give me the mechanism. So what is the mechanism for this reaction? I will give you some hint if you have copied then. Okay, let us say what is the hint is you have to generate an electrophile. What is the reaction? What type of reaction you have in benzene? Electrophilic addition, electrophilic substitution. So you can generate an electrophile in this case. So very easy. You generate a carbocation and then react. To generate a carbocation, you take H plus and you add H plus with oxygen. So lone pair of oxygen can act as a base. And then you open a bond and then you generate a carbocation and do the same kind of reaction 2 times. You have to lose H2O plus also. So enough hint is given to you. So in the first step, you have to add H plus to the oxygen. Then you lose a bond, generate a carbocation. Next step, and generate a carbocation, attack on the benzene ring. In the next step, you lose H2O plus, H2O, generate a carbocation again, attack on the benzene ring. You will get the final product. Let me give you 1 minute time. Not more than that, because this is an easy problem. Okay, I think some of you may have done this one. So let us discuss the solution for this problem. So easy one. So what you have to do is first you have to generate a electrophile. Over here you have, and here you have lone pair. So now H2SO4 will give you H plus. So if you want, you can write the Lewis dot structure of H2SO4. So this take H plus from here. This goes here. So what you will have? If you do this, you will have a 6-membered ring. Yeah, oh my god. So let us copy this here. So you have 5-membered ring, and here you have oxygen and OH plus. You have only one lone pair, so you will have plus. Now the next step, what you can do is you can open this bond. So if you open this one, what you will get? You will get something like this. So I can copy here. So you will have a double bond, 2 methyl group, and then you will have OH, because you have this lone pair is come here. So you will have a positive charge here. Are you getting? So generate this carbocation. Next step is easy. You have to add H plus simply on the benzene ring. So you have a carbocation. Are you getting? I can write the same thing, something like this. So you have OH. There is a carbocation. Now the mechanism for this is first step is electrophilic attack, this next is loss of H plus. I am writing the final product, that is the electrophile generation, and then so addition of electrophile and loss of H plus, both step I am writing in the same time. So minus H plus, addition of electrophile first step, next step minus H plus, that is deprotonation. You will have this. So let me write here. So you can get something. So this carbon is here, this carbon, the same carbon. Now this carbon is connected to 2-methyl group, and then you have some, oh, there is a OH also. So okay, we have written. Now this one. Now in the next step, what you can do is, you can again take H plus. So if you take this H plus, you will have OH2 plus. So you will have OH2 plus, OH2 plus. Are you getting? Because oxygen will take one, so one H plus, so you will have only one lone pair. In the next step, you give this electron to OH2, so you will have a something like this. Only you will have carbocation. So here you have this ring. There is a carbocation. Now the next step, you can add this step. You're getting, so simple. So if you add these two things, I think you are able to write. So if you add this step, you will have this. Now this carbon is connected to this carbon, so I can add these two carbon. So I will get this compound. Are you getting? So what we have done, we have simply generated 2 times electrophile, and then we have done 2 times electrophilic substitution reaction in the same group. Final product is something like this I am getting. So let us copy this one. I think you have copied this one. So simple reaction, nothing hi-fi, only 2 times electrophilic substitution. Electrophilic substitution is done by carbocation. So basically indirect way of generating the carbocation. We have generated the carbocation with ether by losing oxygen bond.